Okay, first thing I want you to do, the top two questions. We're going to do them one at a time. You don't have to do both. But the top two questions are review what we did last time, because we're going to use these skills today. So exercise 1 says solve the following system by using the substitution method. Now, just as an aside, we're having a test on Monday, I already said. If you want to know what the test looks like, there it is. Okay, I told you last time I'm going to put a solve by graphing on the test. I'm going to put a solve by substitution on the test. I'm going to put a solve by elimination that we're going to do on the test. And then I'm going to put one or two more, depending on how I feel, that you can do any way you want. That's what the test looks like so far. Okay, so I'm telling you exactly what's on the test. So do this problem right here by substitution. And just to remind you, because I know it's been a while, maybe you did your homework right away, or maybe you're waiting. My recommendation for you on when to use substitution is when there is one variable that you can see that is the simplest to solve for, meaning one step. So what I want you to do is you're going to go through the whole process, identify in that what's the variable that's the most simple to solve for it, and then substitute it into the other equation. I'm going to give you a couple minutes to do that. If you need anything from me, raise your hand. All right, so as we're looking at this problem, okay, the first equation is negative 5x plus 2y is negative 2. The second one is x plus 6y is 26. Point me in the direction of what is the simplest variable to solve for in that problem. Which x, in the top equation or the bottom equation? Bottom. Why did you identify that? You're 100% right. Why do you identify this x right here as what I'm saying is the simplest one to solve for? What about that makes it such? Perfect. There's nothing to divide by. Yes. So you're looking for some sort of variable that all you have to do is do one step, and that is move the other term. And so in this case, I have to move the 6y. How do I move that 6y? Subtract. So let's do that. So we're going to subtract 6y from both sides. That gives me the equation x equals, meaning x is the same thing as negative 6y plus 26, or you could write 26 minus 6y. The order of those terms doesn't matter. Just make sure you keep the negative with the 6y. Everybody tracking with me so far? We doing all right? Now, the essence of the substitution method is once you've identified that and you've solved, now you take this x value and you plug it in to the other equation. So I'm going to plug it in to the x in the equation that's on top. Here we go. So I'm going to take that top equation, negative 5x. I'm going to write negative 5 in some parentheses. This is my practice that I like to do. That way I don't forget to distribute, things like that. So negative 5 times x plus the 2y is equal to negative 2. And that equation that I just manipulated says x is the same thing as negative 6y plus 26. That's the substitution step. We doing okay? And now this hopefully is beginning to look really familiar because I think we've done this every day of class since the first one. This is just solving an equation. Okay, that's why we do that on the first day. I'm going to distribute, I'm going to collect my like terms, and then I'm going to solve. Okay, I'm going to do this a little, I'm going to speed up a little bit. So if I do anything that's confusing to you, don't be afraid to stop me. I'm here for you. Okay, you're not here for me. I'm nothing special. So negative 5 times negative 6 is 30y. Negative 5 times 26, I believe, is negative 130, but never be afraid to tell me I've done my arithmetic wrong. Plus 2y is equal to negative 2. I'm going to collect my like terms. 30y plus 2y is 32y. Minus 130 is equal to negative 2. I'm going to add the 130. Don't be shy about using your calculator if you need to. Bless you. And what I get, I'm now going to move up to the next column because I've got space there. I've got 32y is equal to 128. And last but not least, I divide. We have solved 1,000 equations in this class so far, and there's going to be 1,000 more to come. Okay, so hopefully you're getting more and more comfortable with that process. And when we pop that into our calculator, it tells us that the y value is 4. So there we go. We've done most of the busy work of the problem, but we've only got half the answer. What do I now need to do with the y equals 4 to finish this problem out? Yeah, you plug it into one of the equations. Yeah, we're just going to go back to the beginning. And just because it is already solved for x, I'm going to use this bottom equation, but you could use either of the other two. It absolutely does not matter at all, okay? So there's no wrong choice here. So I've got x is equal to, so x equals negative 6 times y, so negative 6 times the y value, which is 4. Negative 6 times 4 is negative 24, and then plus 26. So x equals 2, and there's the other half of my answer. And so we write good notation. So you've done all the work. You've done it 100% right at this point. Make sure you get full credit by giving me good notation. The x value's 2, the y value's 4. And so that we know that that is a point and a solution, I put that in braces and I'm done with the problem. Before I have you do the next problem, does anyone have a question, comment, or concern? Anything bothering you about that problem? All right, exercise 2. Exercise 2 says, okay, we're going to solve this system, but this time I'd like you to do it by the elimination method. Okay, so elimination method, remember the essence of that is you want to pick a variable and you want to cancel it by adding the equations together. Now, it doesn't matter which. I'm going to let you choose. Are we going to cancel the x's out of this or the y's? Okay, I heard x's first. So that's what I want you to do. Cancel the x's and then solve this system. If you have anything you want to talk to me about, raise your hand. I'm going to give you a couple minutes. Solve by elimination. We're going to solve eliminating the x's. Just want to give everybody a nudge. So if you're still working, keep working. But if I'm eliminating the x's, as the problem stands right now, I've got a +6 in front of one of the x's, a -4 in front of the other. So what do I need to multiply these equations by to eliminate the x's? Okay, I need to multiply the top one by, what did you say? I'm going to multiply by the lowest thing. So I think I heard somebody say 4 and 6. Let me just say that will work fine. Okay, so if you did that, keep going. Your numbers are going to look a little different. We'll end up in the same place. I'm just going to multiply by the lowest thing. So 2 times 6 will give me 12. So then I'm going to multiply the second one by what? 3. So again, to reiterate, if you did 4 on the top and got 24, then you did 6 on the bottom and have -24. That will work. Don't erase. Okay, keep working. Let me give you another minute, 90 seconds to do the arithmetic, and then we'll finish this up. So the question is, where did the 3 come from? The goal in elimination, I want to have coefficients that are just opposites, so that when I add these two things together, they'll cancel. Okay, so 2 times 6 is 12, +12. And then since I have a -4 here, 3 times -4 gives me -12. That's why I used that. And then that's why other people picked 6 times 4 gave 24. So then -4 times 6 gives -24. So you'll accomplish the same thing. You're just going to have bigger numbers than me. All right, I'm going to get started with the arithmetic. If you have a question about what I'm doing, don't be shy. Make sure you get what you need out of this class. So here we go. And I multiply the top equation. 6x times 2, that is 12x. 5y times 2 is 10y. And then 4 times 2 is 8. The bottom equation, -4x times 3 is -12x. And so now when I add these in just a moment, those cancel. 2y times 3 is 6y, and then 8 times 3 is 24. Now I add the equations together, 12x and -12x, those are eliminated. That's the whole premise of the elimination method. 10y and 6y is 16y, and then 8 and 24 is 32. Gonna divide, and I get y is equal to 2. At this point, it does not matter which equation you pick. I'm just going to use this bottom equation because I have all this space below it to do the busy work. That is the only reason I'm picking it. If you use the top equation, we will both end up with the same x value. It does not matter which one you pick. So y is 2. I've got -4x plus 2 times the y value 2 is 4. Subtract the 4. And we're almost done. I've got -4x is equal to 4. And when I divide both sides here by -4, I get x is -1. So my solution set, x value -1, y value 2, put some braces around it. So the notation tells people reading this that that is a solution, and we're done. All right, so that's review stuff. Before I press on, does anyone have a question about solving a system of equation using either of those two methods? Because that's part of what we're going to do today. You're going to still need that. Yeah. That's what I would pick. I mean, technically, mathematically, you don't have to. You can pick anyone. But our effort is to avoid fractions and making more busy work for ourselves than we want to, right? Like I'm trying to give you the quickest way to get to the solution. That's why I'm suggesting pick something that there's nothing to divide by, and it's one step to solve for. Okay, so what today is about then, how we're going to expand on this topic, is actually solving systems of equations is actually one of the most useful mathematical skills that you're going to probably use maybe in a statistics class if you have to take it, maybe in an economics class when you're comparing different equations for profits and losses and costs and revenues and things like that, in a biology class when you're this is a very practical thing. So what we are going to do to get some experience is we're just going to look at some simple. Now remember, simple doesn't mean easy. We're just going to look at some simple situations so that we can practice the skill of taking something in words and writing equations down. Because I know it's a difficult thing, right? That's not easy for us to do. Okay, so we are practicing with a couple different types of problems, taking something that's written down and making a system out of it, because it's a practical skill that you will be able to use. So I'm going to start. Okay, there's two types of word problems you are going to be responsible for in this class. I'm probably going to put one of each of these on the test that you're going to take Monday. Okay, just FYI. Okay, so no mysteries. So the first type of problem that we're each going to do a couple of is just a problem that you set up using addition. So as we're reading through this together, just want you to think to yourself in each sentence, what's the key word? What is this telling me about my variable? So for instance, example 1, the first sentence says a soccer field is constructed with a perimeter of 320 yards. I'm going to stop there. What would you say is the key word that gives me relationship in that sentence? What was that? Perimeter. Yes, perimeter. Now, in case you don't remember exactly what that word is referring to, okay, does anyone remember how to find the perimeter of something? Add all the sides together. Yes, don't worry about formulas. We don't need any formulas. All the perimeter is saying is add up the sides. So the first couple problems we do, just going to involve the perimeter, just so that we get used to doing this. So I'm going to draw here my soccer field, because whatever you do, it's important that you define your variables so that when you get to the end of the problem, you know what you found. This particular problem, I'm going to define my variables by drawing a quick little picture. You don't have to. You can just write down what each is. I'm just going to go ahead and use, doesn't matter what letters you use either. Since we're trying to find a length and a width, I'm going to use L and W just to be nice and straightforward and clear. So I'm going to say that this side right here is W for width. And I'm going to say that this side here, I'm going to use a capital. This side right here is L for length. We okay with that? We doing okay? So the first sentence says a soccer field is constructed with a perimeter, which means add up all the sides of 320 yards. The second sentence says the length measures 40 yards more than the width. The question is then, what are the dimensions of this particular field? Okay, fantastic. We can do this. Let's go back to the first sentence. A soccer field is constructed with a perimeter of 320 yards. Somebody proposed to me, give me a hypothesis. What do you think that the equation is that represents the perimeter is 320 yards? That's area. Okay, so that would be an area problem. That's not this class, that's college algebra. We will use that. Okay, so good thought. Perimeter just means add up the sides. So what am I going to do if the perimeter is 320 yards? Okay, so length plus width, or X plus Y. I heard somebody using those letters. If those are the letters you're using, that's fine. Do I have anything else to add up? Okay, now before I go to the equals 320, how many sides does a rectangle have? 4. So even though I didn't label them, what's this top side up here? L. What's this left side over here? W. So the area of a rectangle, again, I don't have a formula memorized. I don't care about formulas. I don't memorize them when I don't need to. So I've got L plus W plus L plus W. That is equal to 320 yards. Now, before I find the second equation, let's just combine my like terms. L plus L is 2L, and then W plus W is 2W. And maybe some of you remember that from middle school geometry. That's how you find the perimeter of a rectangle, but there's no need to memorize any sort of formula. Okay, the second equation says the length measures. Measures is a relationship word. It's telling you that there is a comparison here, that the length measures, the length is the same thing as 40 yards more than the width. Now, this one might be a little harder the first time around, but it'll be a little easier when you do your problem in just a couple minutes. The length, what variable am I using for length? L. Measures, or is the same thing as, so I'm going to use equals. And now make a proposal for me. L equals 40 yards more than the width. What is that as an expression? What operation do you think you might use for more than? If I have $40 more than you do, which is not likely, not multiplying, addition, more than, okay? You would take whatever amount of money you have, and then if I have 40 more than, it's plus 40. Okay, so the length is 40 more than the width. Now we're going to solve the first couple of these just to practice solving. This one is given to us to substitute. It's kind of straightforward. If you want to eliminate, you're going to bring the W over to the other side. Elimination, you have to have the variables on one side, the number on the other. That way you can go. So I'm just going to now say, okay, L is the same thing as 40 plus W. I'm going to substitute it. So I've got 2L, so 2 and some parentheses, plus 2W is 320. L is 40 plus W, so 40 plus W right there. And we just did this a few minutes ago. I'm going to distribute. I'm going to collect my like terms. Then I'm going to solve. 2 times 40 is 80. 2 times W is plus 2W. Plus the 2W outside the parentheses is equal to 320. Collecting my like terms, 80 plus 2W plus 2W, that's 4 of them. I'm going to subtract 80 from both sides. $4W is equal to 320 minus 80. I believe the calculator will tell me that's 240. And when I divide both sides by 4, I get that W, which is what I have used for width, is 60. Second to last thing to do, I'm going to take that W of 60. I'm going to come over here and say, okay, L is 40 plus W, 40 plus 60, and 40 plus 60, L is equal to 100. We're doing a word problem. So then the very last thing to do is answer the question. The question in this case is, what are the dimensions of this particular field? Now, always make sure you're answering the question. In MyMathLab, there's some problems like this that just says, what's the length? Okay, or what's the width? So don't answer the question that's not there. Okay, answer what is there. This one asks for both dimensions. I'm just going to come over here to the left part of my paper where I have a little space to write, and I'm just going to quickly write the answer to the question. Okay, so the width is 60. And I believe my units are yards. The width is 60 yards. And the length is 100 yards. And there we go. So I'm going to leave that right there so you can look at it. I know you have it written on your page probably. I want you to look down exercise 3, the last problem on this page. It is pretty much the same problem. Okay, you just now get to go through and reinforce what we've just done. So do your best with exercise 3, set up that system. If time allows you, solve that system, and then we'll compare notes in just a minute or two. All right, so I'm gonna get started. The real important skill here is please ask a question if you're having trouble setting this up. That's the new thing we're doing. The solving the system, that's hopefully you've practiced that, or you will practice that when you go back and you do your homework for the section 3.1. So this time we've got a rectangular parking lot. I've drawn the same picture as I did before, L for length, W for width. The parking lot has a length that is, the word is my relationship word. It means equals. Anytime you read is in a problem, that's equal. It's giving you the relationship between the two sides. The length is 10 feet more than twice the width. So let's stop there. What equation does that tell you to set up? The length is 10 feet more than twice the width. L equals 10 plus. If you don't know what the word twice means, can anyone tell us what the word twice means? 2 times. Okay. Twice means 2 times. So if you didn't know that, then sorry about that. Now you do know that though. Twice means 2 times. So the length is 10 plus twice the width. So 2W. The perimeter of the parking lot is 620. So what's my equation for the perimeter of the parking lot? Okay, it's equal to 620. That's great. Equals 620. What am I adding up to get 620? Yeah, so if we look back at our picture, okay, I've got L plus W, L plus W plus L plus W. So that is where I get 2L plus 2W. Just adding up all 4 sides. So solving it, this is pretty much the same thing. I'm just going to go through this. I'm going to take the L. I'm going to plug it in right here. So I've got 2 times L plus 2W is 620. The L is 10 plus 2W. Distribute. This is the same steps I just went through. The steps never change, which is the good news. Once they click, you're doing the same thing every time. Collecting my like terms, I've got 20 plus 4W plus 2 is 6 of them. I'm going to subtract 20. And I get 6W is equal to 620 minus 20 is 600. And last but not least, after I do my great division here, 600 divided by 6 is 100. There's my width, 100. The length can be found by using either of the 2 equations over here that I started with. I'm going to use this top one. The top one says that the length is 10 plus 2 times the width. That's 2 times 100, or 200. So 210. Now I'm going to answer the question. The question is, what are the dimensions? So the width is 100, and I think my units here are feet. And the length is 210 feet. All right, we're going to keep practicing this. I got more problems for us, but before I move on, any question, comment, or concern? Anything you're hung up on here? Okay, I'm flipping the page. My next example, we're going to alternate. I've got one, you've got one. It's another problem just involving addition, but it looks a little bit different. In fact, my class before you, they liked this one a lot better. So example 2 says this. For the 2012-2013 season, 2 hockey tickets and 1 basketball ticket cost $173.01. 1 hockey ticket and 2 basketball tickets cost $162.99. What were the cost of each ticket? We lost our receipt, so we want to know. So to save time, because we've got a bunch of problems, and today's new skill is the translating of the problem into a system. We're just going to set the next ones up. If time allows us at the end of class, we'll go back and solve some of these, but I want to make sure that we get all of these set up. So we're going to set up the system here for example 2. So I've got two things I don't know in example 2. What are the two things I don't know that I'm looking for? Okay. Yeah, hockey ticket and a basketball ticket. So I'm just going to use the appropriate letter. I'm going to use B for basketball. And then H for hockey. Again, the letters that you use do not matter. Declare them so that when you get to the end of the problem, you know which is which. Okay. I'm trying to use an obvious letter, and I'm also declaring them just so that when there's no confusion at all. All right, so let's set up this system. I'm going to reread the first sentence, and then you're going to make a proposal for me and see what this equation is. So the first sentence says 2 hockey tickets and 1 basketball ticket cost $173.01. So what do you think that looks like as an equation? Okay, 2H plus B equals 173.01. Lovely. 2 hockey tickets, 2H plus 1 basketball ticket, 1B or just plain old B, cost, meaning there's my relationship word, 173.01. Perfect. The next equation comes from the second sentence, which says 1 hockey ticket and 2 basketball tickets cost $162.99. What is that equation going to be? Okay, we're going to have a 2B plus H. I'm just aligning up the variables the way they were in the first one. Okay, so that way when I go to eliminate, if that's how we solve this problem. So H plus 2B is equal to 162.99. Now, as I said, we're not going to go through the whole process of solving just to save a little time, but I do want to give you the nudge in the right direction. If we were going to solve this, if we were going to eliminate, because this one's set up to eliminate, let's say we wanted to eliminate the H's. What do I have to do to which equation to eliminate the H's? I'm going to multiply the bottom one by -2. Because I have a positive 2H in the top equation, so I need a -2H on the bottom equation. Great. And from there, you can go and you can solve. And if we have time, we'll come back and we'll take a look at that. Here's what I would like you to do. Exercise 4, super similar problem. I'm going to give you 2 minutes. Read through the problem, define your variables, and then set up the system of equations you're going to use to solve that problem. You don't have to. You could substitute if you want to, for sure. Either method, elimination or substitution, will work for every problem. It just basically just depends what the setup of the problem is. This one right here would probably, you're right, work just as equally well with either one. We could solve this one for H and then substitute. I only decided I wanted to eliminate because of the setup of the equations. They're all both set up on the same side. All the variables are on the same side. That's the only reason I made that determination. Okay, so here's what I'm going to do. I'm going to use the letter G for general admission. And then I'm going to use C for children's. If you use different letters than me, don't erase, that's fine. Okay, just make sure you have declared what they are. So when you get to the end of the problem, you know what your X and your Y or your M and your N or whatever your favorite letters are, what they represent. Okay, so the first sentence says 2 general admission tickets and 3 children's tickets cost $239.95. All right, so what is that equation going to be? 2G plus 3C equals $239.95. Does anyone disagree with that? Does anyone have a question on why it's 2G plus 3C? Okay, second equation. 1 general admission and 4 children's cost $224.95. What's that equation? Perfect. G plus 4C, 1 general admission plus 4 children's is $224.95. Great job. Again, on this problem, you could substitute. You could bring the 4C over and solve for G. But again, just to give you a nudge about elimination, let's say we want to eliminate the G's on this problem. Talk me through. What would my process be to eliminate the G's if I used elimination? Perfect. -2. Yep, you got it. Yeah, I know that's what you meant. You got it. Perfect. Right. We doing okay? All right. So that is the first style of problem. We did 2 examples each of the first style, which is called, and it's just an addition problem. You're setting up problems, setting up equations using addition, and then you're solving. The second style of problem that you are responsible for, and we're each going to do 2 examples of as well, it's called a mixture problem. Okay, we're going to talk about mixture problems here. Before we do that, I just want to give a quick reminder of how percentages work. Okay, I find sometimes students, maybe that's faded into your memory, and a lot of the mixture problems involve using a percent, and I don't want that to be a stumbling block. So let's pretend after class, you're really thirsty. So you decide you're going to go to the store and you're going to get a bottle of apple juice, okay, because that's your favorite kind of juice. So here is my best drawing of a bottle of apple juice. Ooh, it looks more like a jug, but that's okay. Okay, so this is my apple juice. And we're getting, just keep numbers around, we're getting 1,000 milliliters. We're getting a liter bottle of apple juice. Oh, we're excited. Nice and cold. We're ready for it. As you're walking to the checkout station, here's what you notice on your bottle of apple juice. It's only 30% juice. Okay. So whatever else is in the bottle, 30% of it is juice. The rest of it is other stuff, water and sugar and whatever else they put in juice. Okay. So here's my question. As you're looking at that, how would we use those numbers to calculate how many milliliters of the volume is actually apple juice? What am I going to do to figure out the volume of apple juice? I'm going to take these one at a time. Turn what into a decimal? Who said that? Okay, how do I do that? Turn the percentage into a decimal. What do I do? Move it to, percent is a ratio per 100. And so then the way we turn 30% into a decimal is you move the decimal place left 2. So instead of 30%, it's 0.30. And what do I do with 0.30 and the 1,000 milliliters that are in the bottle? No, not divide. I'm going to multiply. Yes. So percents never stand by themselves. A percent is always a percent of something. Okay. So when you go to McDonald's and you have a 25% off coupon, well, the amount depends on 25% off of what? How much are you spending? Okay, the 25% doesn't mean anything unless you have something to go with it. And that's why I'm just reminding you here of percents. So as you're walking to the checkout person, you say, oh, 1,000 times 0.30 is, there's actually 300 milliliters of juice in my juice bottle. The rest is all other stuff. That's just a quick reminder on how percents work. Okay. Now here we go with the mixture problem. I know mixture problems are not easy. My goal is to get us a little experience. There's a bunch more in my math lab, and I'm hoping that while it's still fresh, you'll get yourself to my math lab as quick as possible and practice more. Okay, because I understand this. In my mind, this is one of the probably the hardest thing in this whole unit that we're going to do. There is going to be a mixture problem on the test, I promise. So here goes. Example 3 says this. You're in chem lab. You're a mad scientist, and you need to know how many ounces each of a 5% hydrochloric acid and a 20% hydrochloric acid must be combined to obtain 10 ounces of a solution that's 12.5% acid. Okay. So you don't have a 12.5% in your closet. All you have is 5 and 20, and I want to know, as I'm dumping the beakers into a bowl or whatever I dump beakers into, how much of each need to go into the bowl so that my output is 10 ounces of 12.5% so that I can do whatever experiment I'm going to do. So acid is like the juice in my example. I don't know if you've had chemistry or if you ever take chemistry, but if you ever encounter an acid and you see the liquid, it's not 100% acid molecules. Okay, that would just eat through the earth. Okay, acid is always a mixture of acid molecules and water. Okay, just like alcohol, whether it's rubbing alcohol or drinking alcohol. Okay, that is alcohol molecules and water. Okay, it's a percentage. Okay, so you're going to see these different things used in your problems. So here's what we're going to do. This is my structure for mixture problems. This is how I think about them. So I'm hoping that this will be useful to you. If it's not, the My Math Lab has another way that they'll show you in one of the problems, but here's what I like to do. I like to use a box to represent the things I'm adding together. So here's my first box, and then I'm adding a second thing to it. So here's my second box for the two things I'm adding together. And then I'm going to put an equal sign, and then I'm going to draw another box over here for my result. And what I'm going to do is I'm going to fill in the information on these boxes, because that's always the challenge in a word problem, is discerning the information. I'm going to fill in the information on these boxes so I can make my equations. Here we go. The first thing I'm going to do is I'm going to label the attribute of each box. So what's the first thing that I'm adding together according to the problem? A 5% solution. So I'm going to write 5%. That box represents how much 5% solution I'm dumping into my bowl. What's the second thing I'm adding in? A 20%. So this second box represents the 20% solution that I'm dumping into my bowl. And I want my 5% plus my 20%. What do I want my result to be? A 12.5%. Yes, great job. So far, so good. So what I'm going to do across the top of the boxes is I'm going to put across the top of the boxes the total amount of each. So according to the problem, am I told how much of the 5% I want to add in? Does it say an amount for the 5%? No, what does it say in front of the 5%? It says how many ounces? So I don't know, right? So when I don't know something, what do I use? Sure, X, a variable. You use a representative. So I'm going to call that X. I don't know how much 5% I'm adding. All right, let's try again. Am I told how much 20% I want to put in? No, I'm not. So what am I going to call the 20%? As we look to the end of the problem, am I told how much 12.5% I want to have? Yes, I want to have 10. I want the amount of the first acid plus the amount of the second acid. When I combine those two things together, I want the total amount to be 10 ounces. Okay, that's what I want my result to be. Now what I'm going to do is I'm going to say, okay, I know acid, I want to how many acid molecules. So the top thing is the total amount of each. The bottom thing is the amount of acid. Or if you're doing a problem amount of alcohol or another problem amount of juice. Those are the different substances you're going to see in your MyMathLab problems as you're practicing. So just like we saw for the apple juice, if 5% of the volume of this box is actually acid molecules, what's the decimal I'm going to use for 5%? 0.05, and it's 0.05 of what? What's the total amount in the box? What have I called that? X. Yep, 0.05x. 5% of the volume, which is 5% of X. Let's try again. We're practicing. We're getting better at this. Okay. So the next one, I've got 20% of this box is acid molecules. So what's going to be the expression for the total amount of acid in the second box? 0.2 what? Y. Yep. Or 0.20 Y. You move the decimal twice. What am I going to do on the other side to figure out how much acid is in the last box? I'm going to move it and multiply. Yes, that's exactly right. I appreciate that. So 12.5% is 0.125 times 10. Remember, percents never stand alone. It's always a percent of something. So it's 5% of the X. It's 20% of the Y. It's 12.5% of the 10. Okay, the percent applies to a total. Now I have information to make two equations. The first equation is just what do I get when I look at the top? The top is the X plus the Y equals 10. That's the total amount. The second equation is what I get when I look at the bottom of the box. So that is the amount of acid from the first one, 0.05x, plus the amount of acid from the second one, 0.2y, is equal to the amount of acid in the final thing, which is 0.125 times 10, which is 1.25. Now, again, we're not going to solve this system, but I do want to give you one pointer because I'm guessing we don't like fractions. We probably don't much like working with two-digit decimals either. So if you're going to solve this, here's what I would recommend you do. I would recommend multiplying this bottom equation by something that makes whole numbers here instead of decimals. Does anyone have an idea? Maybe you've seen this before, or maybe you're good with arithmetic. What am I going to multiply all three of these things by to move my decimals? Why'd you pick 100? That's 100% correct. Yeah, they have to move two places. Yep. And you have to, I know this middle one only has to move one place, but you always have to multiply everything by the same thing. So we're going to multiply by 100, two decimal places. And you can verify in your calculator. 0.05 times 100 is 5. 0.2 times 100 is 20. 1.25 times 100 is 125. So now you have numbers that do not have decimals anymore, and then you can go ahead and solve that by elimination probably, or substitution. Either one would work probably equally well in that problem. I'm going to leave that right there. Exercise 5 right below is an almost identical problem. I've just changed the numbers in minor ways so that you get to validate and to reinforce what we just did. So give the next exercise your best shot. let's see how you're doing and progress. You can give me any feedback, ask me any questions you need to about what's going on. So the problem says how many liters. So I've changed the units to liters instead of ounces. So big change there. Each of a 15% acid and a 25% acid should be mixed to obtain 30 liters of an 18% solution. So first thing I'm going to do is I'm going to label the attribute. So the things that I'm adding together are a 15% solution and a 25% solution. And we're doing that in order to get an 18% solution. So I've got that. Now you're going to help me with the rest. So for my total amount that I'm going to put on the top, how much of the 15% solution am I putting into this mixture? Yeah, I don't know, right? So who was saying it? Say it loud and boldly. X. Perfect. Not quite loud and bold, but we're going to work with what we got. How much of the 25% am I adding? I don't know. So I'm going to call that Y, or whatever your favorite letters are. It doesn't matter. How much of the 18% do I want to have? 30. And I'm going to use an L for liters. 30 liters. Great. Now, across the bottom of the boxes, I'm now going to put the amount of the acid that's actually in the box. So on top, that's the total amount in the box, total amount of liquid. And on the bottom is going to be how much actual acid molecules are there. So what's going to be the expression at the bottom of this box that represents how much of this first solution, or how much of this first solution is acid? 0.15 what? X. Percents never stand alone. It's always a percent of something. How about the next one? What's the expression at the bottom of that box? Perfect. Way to fix the mistake. I love it. You're learning. That's a great job. And then what's the expression at the bottom of the third box to represent how much acid is in there? 0.18 times 30. I know this is hard stuff, everybody. I get it. Okay, so practice and build some memory of this. Okay, please, I will never tell anybody that mixture problems are easy things to do. I totally get it. So here's my two equations. Well, you tell me what's the top equation that represents the total amount of substance? Yeah, I'm just going to leave the L off because that's the units. But yeah, X plus Y is 30. That's perfect. Well said. Thank you. And then what's the equation that represents the amount of acid? Perfect. So 0.15x, the first box, plus 0.25y, second box, is 5.4, which is what 0.18 times 30 is. Again, we're not going to solve it just for time's sake because we're running a little bit short here. What am I going to multiply, though, all three of these terms by to get rid of those decimals? Again, 100. And again, I know the last one, 5.4, only has one decimal place, but you have to multiply everything by the same. All right, flip the page. I've got one more, you've got one more. It's another mixture problem, but this time it's not a mixture problem with percents, it's a mixture problem with money. But it works the exact same way as what we just did, okay? There's going to be no real difference. So in example 4, we've got a grocer, and she has some $4 per pound coffee, and she has some $8 per pound coffee. And she wants to make a mix that's going to be right in the middle price-wise of both of those. So she wants to mix these two coffees in order to make 50 pounds of a $5.60 per pound coffee. So how much of each does she have to add in order to accomplish this? So again, I'm going to draw my boxes. The only difference here is that the attribute is not a percent, it's a cost. So on this one, this grocer, she finds that she has some $4 per pound coffee laying around. So that box, whatever's in that box, costs $4 per pound. And then she has some $8 per pound coffee. So what's in that box costs $8. And again, she wants to make a mixture that's price-wise going to be right in the middle of that. So about $5.60 per pound. So again, what we're going to do is on top of the box, we're going to label the total amount in each box. So what does the problem tell us about how much $4 per pound coffee she's going to add? Yep, it doesn't say anything. So X, yeah. I'm not trying to confuse you, just trying to make sure you're reading the problem and know that it doesn't give us any amount. How about what does it say the amount of the $8 coffee is? Y, that's what we're looking for, those two things right there. What's the amount of coffee she wants to have at the end? 50 pounds. Okay. And so now at the bottom, now we don't have a percent. What we're going to do is we're just going to calculate the cost. So if in this box, I have X pounds, I don't know how many, but if I have X pounds of coffee that costs $4 a pound, well, the total cost of this box, if you were going to buy the whole box right here, would be, what's that? 4X, yeah. $4 for however many pounds it is. So then the next one, the next box is Y pounds. And this coffee costs $8 per pound. So if I was buying this whole box, how much would I pay for that box of coffee right there? 8Y. Yep. $8 per pound times how many pounds, which I don't know. And then what's the expression for how much the result costs? Yep. It's $5.60 per pound for 50 pounds. So to get the total cost there, I'm going to multiply those two things together. Great. So here's my two equations. The top equation is the amount of the first coffee, X, plus the amount of the second coffee, Y, is equal to 50 pounds. And then the second equation is the first box costs 4X, the second box costs 8Y, and the result is 560 times 50. That's too much mental arithmetic for a Monday. So let's use a calculator. So 560 times 50 is equal to $280 is how much that result is worth. I don't have any decimals to move, so I would just go and solve it from right there. If you have a question about that, be sure to ask. Here's our last problem of the day. It's another problem just like that, except instead of coffee, we're making party mix, which sounds fun. So go ahead, I'm going to give you a couple minutes, set up the system of equations you're going to use to solve exercise 6, please. All right, so for time's sake, I'm just going to get started. Here we go. So a party mix is going to be made by adding nuts that sell for $2.50 a pound to a cereal mixture that sells for $1 a pound. So how much of each should be added to make 30 pounds of a mixture? That will be $1.70 a pound. So again, so how much does the stuff in this first box cost? Yep, $2.50, 2.50. How much does the stuff in the second box cost? $1. And then how much does the stuff in the third box cost? Okay, great. According to the problem, let's fill in the total amounts. How much of the 250 nuts are we going to add? We don't know, so we're going to call that X, or whatever your favorite letter is. Use your initials, it doesn't matter. Okay. How about the second one? How much of the cereal mix are we going to put in? Again, we don't know. We're going to call that Y. How much do we want this to add up to at the very end? 30 pounds, for sure. That gives me my first equation. X plus Y is 30. We'll write that down in a minute. Okay. What's the value of this box right here? All these nuts that are in this box, what's the value? Perfect. $2.50 X. What's the value of this second box? 1Y, or just Y. And then what's the value of this third box right here? 1.70 times 30. Well done. So my top equation is just going to be the total amount. It's the amount of $2.50 nuts I'm putting in plus the amount of $1 cereal mix I'm putting in, and that's going to equal 30 pounds. That's all we want to sell. The cost is $2.50 times X plus 1Y, and then $1.70 times 30, 51. Perfect. Thank you very much. And then if you don't want to work with that decimal, what would we multiply everything in that bottom equation by to get rid of the decimal? 10. Yeah, because that 0 here, you're right, it has no meaning. So we're just going to use 10, and there we go. Good deal.